Hello, welcome to the joint session between AWS and Aerospike on how to deploy mission-critical workloads on the cloud in a sustainable fashion. I am here with Amit Shah, who is one of the senior leaders of product management at AWS EC2. Amit is an expert in data center storage and compute offerings. Currently, he's at AWS and manages the storage optimized instances for EC2. Amit, welcome.
Yep. Thank you, Srini. Hey guys, so why don't we talk about what is it that we're going to discuss today? A few things. We're going to talk about why mission critical workloads are running on cloud. Like, what is it that is so compelling with cloud that we see a lot of mission critical workloads move to cloud, and then how is cloud driving sustainability? And I'm sure this is really important for you and your company and your business. So we'll dig a little deeper into that. We'll also talk about Graviton and how Graviton is helping change the whole sustainability scenario. At that point, I will transition over to Srini, and then Srini will come back, talk about how their customers are using mission critical, enabling mission critical use cases using Aerospike. So he'll dig deeper into that, how Aerospike is enabling reduction in the server footprint. And then he's going to talk about the plans for Aerospike on Graviton, which I'm really excited to hear about. So let us start with the first topic, sustainability on AWS. So let us talk about, like, before we dive deeper into sustainability and all of that, I thought, like, I'll take a moment to talk about what is mission critical workload. What does it really mean? And I think the way I would want to define it is that mission critical workloads hold sensitive data, which is business critical, or it needs to conform to privacy policies or regulation. So in this particular scenario, security of that data is of utmost important. So that is number one. These workloads need to be aware. This workload or the data associated with the workload needs to be available 24/7, or else there is a material impact to the user. That is what it makes it mission critical. And when I talk about material impact, it means that either we would not be able to meet a customer SLA commitment that we've already provided, or there's a big business impact resulting in thousands of dollars of loss per minute. And another important aspect of mission critical workload is that the data needs to be resilient. This means that the architecture and the deployment should be such that the data is protected under various conditions that the infrastructure might encounter. So all of these combined really help define what mission critical is. And I'll talk about how mission critical workloads are run on AWS. So when a customer starts thinking about, okay, why do I run mission critical workload on AWS? What are the key vectors that benefit the customer? Then the few important things that come to my mind is, number one, AWS offers hundreds of instance choices, to enable you to evaluate new ideas and drive innovation that benefit your customer. So the speed at which you can innovate, the speed at which you can figure out, okay, what is working, what is not working, where do you optimize? With all this offering that you have, it is going to be really, really fast for you to experiment and figure out how to drive innovation quickly and add more value and reduce your cost. On top of it, it is cost effective. You only pay for the compute power, storage, and other resources that you use without any long-term contracts or upfront commitments. Basically, the idea is that you take advantage of the conceptually infinite scalability of the cloud without really paying all that CapEx right away at the beginning of it. The third important part is you eliminate guessing your infrastructure capacity needs when you ultimately transition to cloud. So the background here is that when you have to make a capacity decision prior to deploying your application, you often end up either sitting on expensive idle resources or dealing with limited capacity, which then hurts you scale to your peak demand. With cloud computing, these problems go away. You can access to as much as few number of instances to thousands of instances and scale up in a matter of few minutes. The other angle that I would want to talk about is AWS is designed to allow application providers, ISVs, vendors to quickly and securely host their applications on AWS, which means that you're focused on enabling your differentiation, creating value for your customer, rather than putting all your resources on infrastructure, which is not really going to be your key differentiator or value add. And then the last thing why people really love working with AWS is the big global footprint. AWS spans 84 availability zones within 26 geographical regions around the world. And we've already announced 24 more availability zones and 8 more AWS regions coming up. So again, if you want to start in US and want to quickly scale to Asia and from there to Australia, meaning all of this can happen instantaneously. So if you dig deeper into the kind of offerings we have, and I'll not go into the details of it, but what I want to highlight is that you see that there are many such categories that we support today. So depending upon your workload and what your SLA commitments are and the TCO requirements you have, you can figure out what is the category that best suits your workload requirements. And then within that category, we have multiple choices. You have choices for the kind of CPUs you have, amount of storage, amount of networking, memory, all of these choices are clubbed together, and then you have EBS offering on top of it. So today we offer more than 475 instance type so that we help you optimize your workload and give you the best price performance. So how does Aerospike fit into all of the scheme that AWS has? Number one, like when we started working very closely with Aerospike, we figured out that having access to the latest infrastructure and having access to instances which are Aerospike certification tool optimized is going to be of great benefit to Aerospike. So that is what you get. With AWS, you get the latest, greatest offerings with the latest CPUs, latest storage technology, and we have custom built our AWS Nitro SSD to be delivering 60% lower latency and up to 75% lower latency variability because of our tighter collaboration with Aerospike. We know that the hybrid memory architecture configuration thrives on lower latency and lower latency variability, and that is where IM4G, IS4G, and I4I offering are enabled to really create value for Aerospike use cases. Apart from that, we also have offerings for all DRAM configuration, anywhere from 1 terabyte to 4 terabyte of DRAM capacity with the M6i, R6i, X2 and many more such offerings. So let me talk a little bit about the sustainability goal. Like how does all of this tie together to the sustainability thing? So first of all, Aerospike and AWS, as AWS, we are 100% committed to sustainability. If you look at when you factor in the carbon intensity of consumed electricity and the renewable energy purchases that AWS make, we are going to be, when I say we, AWS infrastructure is 88% lower carbon footprint and 3.6 times more energy efficient. Yes, 3.6 times more energy efficient than the median US enterprise data center. So that's a substantial energy optimization that we drive within AWS. The other big area is our focus on renewable energy. Amazon now has 232 renewable energy projects all around the world, including 85 utility scale wind and solar projects and 147 solar rooftops on facilities and store worldwide. Our plan, and we are on track to be 100% renewable energy by 2025. And then to sum it up, we have a long-term commitment to be net zero carbon across our business by 2040. That is 10 years ahead of the Paris Agreement. So again, we are doing significant number of things to make sure that we drive performance, but in a very sustainable fashion. And this is not where we stop. What we have done to further our sustainability agenda is Graviton processors. So these are custom designed by us and deliver up to 3.5 times better performance per watt. That is because of lower power, higher density, and lower cost that it delivers at a solution level. We are the newest generation of Graviton, which is AWS Graviton 3. These are 60% more energy efficient than the comparable EC2 instances. So I think you've heard enough from what AWS is doing for mission critical workloads and sustainability. And at this point, I would want to pass on the baton to Srini, who's going to talk about what is Aerospike planning to do. Srini, you want to take over?
Thank you, Amit. That was fascinating to see the amount of sustainability innovation that AWS has been driving. Let's now take a look at what Aerospike brings to the table. First, I want to point out that when Aerospike started, maybe 12 years ago, I think around, we were mostly focused on bare metal deployments. But over the last 10 years, all of these mission critical applications, many of them have successfully migrated to the cloud. So our partnership with AWS is really important in that aspect. And we are also bringing that level of mission critical behavior to the cloud. Now, let's take an example of this particular use case, which is in the area of figuring out real-time threats, so to speak, in terms of logging into various systems as a person. Like, for example, banks typically use this service from threat metrics to identify users who are logging into the system to see whether they're legitimate or not. The biggest challenge here is essentially to prevent false positives, as well as to be able to make sure that you can handle a lot of transactions per day and also keep the cost per transaction down while also provide predictable SLAs. Now, the original solution that was being used before Aerospike was deployed in this particular deployment had enormous server sprawl. You will see this in many in-memory database deployments over the years. I mean, we've seen it over and over again where we've replaced these kinds of situations without technology. I'll go into that in a second. But the idea here is when you have a lot of servers, it is harder to, first of all, produce this predictable latency. The SLAs become unpredictable, and the per API cost in this particular case becomes not conducive to running a profitable business. So when Aerospike essentially ended up deploying in this case, the 450 database nodes that were being used were reduced to 30. And that essentially provides a lot of savings and so on, but a lot of it is about sustainability also. Now, to give you, an idea of the kinds of savings that were gotten here, we can look at the actual performance and latency comparison between Aerospike and the other database. Now, in this particular case, the application level, about 1/3 of latency was reduced. But at the database level, that's what you see on the left with the circled latency differences between the before Aerospike and the after Aerospike setup. Now, if you look at on the right side, the database latencies themselves dropped from multiple milliseconds, like 5 to 6 to 7 milliseconds, down to a fraction of a millisecond to about 0.2. Now, since a particular application transaction ends up accessing a lot of database records, and that's one of the important things about Aerospike is accessing more data in real time to provide better decisions is what makes this whole thing work. And if you can do it with lower resources, then you make it more sustainable for these kinds of applications. This is another kind of application where it is about fraud detection. It's one of the large payment providers, essentially using Aerospike to detect fraud in real time. And if you look at this kind of solution, the solution they used before was using a relational database management system with 360 caching servers in front of it. And all of that was reduced to just 20 Aerospike servers. And again, it is due to this hybrid memory architecture that Aerospike supports. And what it enabled this particular use case to do is to provide a more predictable SLA so that they can essentially prevent fraud more effectively in real time. So this is actually the before and after graph like we saw before. You can see that there was about 1.5% of SLAs missed before Aerospike and less than 0.05% of Aerospike, of SLAs being missed, which means for a 300 million transactions per day, at risk was about 5 million a day or $1.8 billion per year on the left side, while that's reduced by 30 times to just about $170,000 a day or 62 millions per year. These are transactions which are executed without a fraud score because the SLA was missed. So you can see how this could create a material improvement in the business. But all of this is being done, which is kind of the important point, is with far fewer servers, like 20 instead of 300 in this case. And how is this even possible, you might ask? Aerospike uses a hybrid memory architecture where we have leveraged flash storage extremely effectively to provide very high throughput read-write real-time transactions. We have various kinds of hybrid memory over the years we've developed. We started off with storing the index in DRAM and the data directly accessed from flash, which we call it that was the original implementation of Aerospike hybrid memory. We have since then extended the hybrid memory implementation to use PMEM for the index as well as, and while still keeping data in flash, which increases server footprint reduction further than the simple DRAM to flash configuration. I'm comparing it to pure in-memory solutions, which is kind of what you will see in the next slide. And then we also built out an all-flash system where the index and the data are both in flash. It obviously uses the flash up more, and you give up some level of latency, but however, you can make the system even more sustainable. And for a vast majority of applications in the core of the enterprise, a 5 to 10 millisecond response time is more than enough. So again, looking at in-memory versus hybrid memory comparisons, these are from real deployments with customers over the years. What you can see on the left is 450 servers reduced to 60 servers, and on the right you see 200 servers reduced to 30. Now, all of this essentially increases sustainability while allowing businesses to scale as they need to scale in order to satisfy their specific application requirements and customer experience. Last year, Aerospike worked with AWS and Intel to demonstrate how efficient we can be on the cloud. In this particular case, we were able to show millions of transactions per second running on just 20 i3-EN nodes. Since then, as Amit explained, there are a lot more new instances that are either in the pipeline or already released, and all of this is just going to increase the sustainability even more on AWS for Aerospike. We are also extremely excited about Graviton. We have run some lab tests on Graviton and Aerospike, and we demonstrated that it can provide 40 to 60% higher price performance on Graviton than we've seen earlier. Also, a lot of the energy savings that AWS has shown, as Amit presented before, all of that will be preserved by Aerospike on Graviton, and while also delivering the highest performance on any cloud for Aerospike by running Aerospike on Graviton. We expect, we already have, as I said, a lab version of it we've been testing for a while, but Aerospike on Graviton is part of our roadmap, and it's going to be generally available in the second half of this year. We're really excited about this particular development. Some of the key takeaways here, AWS by nature of being the largest cloud, but also being very innovative and and being, I think, and they've actually essentially demonstrated a huge amount of energy efficiency, as Amit pointed out, almost 3.6 times more than the enterprise data centers in the US. What this means is with the Aerospikes, when you combine this kind of massive reduction in, or this kind of energy efficiency with the massive reduction in server footprint that Aerospike brings, which is further boosted by the Aerospike running on Graviton, which is supposed, which will be happening soon, what you will get is sustainability, which will help us continue to make progress to reach that net zero goal that Amit talked about, much earlier than we think it can be done. So this is really exciting. And over the last few years, our partnership with AWS is become really close, but also it's starting to pay real dividends in terms of how our customers are able to leverage the combination of Aerospike running on AWS in order to satisfy their most stringent mission critical requirements while also being sustainable. Thank you.